Welcome back to Chapter 4. We're looking at Section 2 now, which may seem a little bit weird because we jumped ahead. Now we're going back. But this section and the next section, we're going to be looking at solving these systems of equations algebraically. We have two different methods that we use, and we'll see why we like doing this as opposed to solving them graphically in just a couple minutes. Remember, though, that a system of equations is the two lines, kind of like we have here. We've got this red line and we've got this blue line, and then the solution is this point where they intersect. So that's what we're trying to find. Graphically, we could see it visually, and we could look, it's like, all right, so this one we went over 0.6-ish, and we went up like 0.4-ish, maybe 0.5-ish, but it's not really on a nice place. So this one would be really hard to solve graphically, and that's where solving it algebraically will come in very handy. So our learning targets, we can use solve systems of equations using the substitution method. That's what we're going to be looking at today. It's just one thing that we're going to be looking at over and over and over again today. We'll see a bunch of examples on the exact same thing. So what is the substitution method? How do we solve these by substitution? So the directions for all of these, just what is the solution to the system of equations? And now we have a system of equations. We have y equals 6x plus 7 and 3x minus 8y equals 4. And we want to find that point where they're both the same. So to do that, we are going to first solve for one of our variables. We actually have that in this top equation. We have y equals 6x plus 7. We're going to take that and we're going to replace this y down here in the other equation with what y equals. So we're going to have the 3x minus 8 times y equals 4, but instead of y, we're going to put what y equals, which is 6x plus 7. Now we have one equation with one variable. We did this a couple chapters ago. The first thing we're going to need to do is we're going to need to distribute to get rid of these parentheses. So that's going to leave us with, we have the 3x, then we have negative 8 times 6x is negative 48x, negative 8 times 7 is minus 56 equals 4. We can move all the non-x's to the other side. So let's add 56, and then we can combine our like terms. 3x minus 48x, 3 minus 48 is negative 45x equals 56 plus 4 is 60. So we have negative 45x equals 60. And the next step, we have to get that x by itself. So we're going to divide by negative 45 to get x equals, well, we know it's negative. And then 60 over 45, we could divide both of those by 15 to reduce to get negative 4/3. So x equals negative 4/3. That's not the answer yet. That's part of the answer. Remember, our answer is a point. It's an ordered pair. So we'll have negative 4/3 comma something. How do we find the other one? We take the x and we plug it back into one of the original equations. I'd recommend the one where we already have y equals something. It's probably going to be easier. So we have y equals 6 times x, which is negative 4/3, plus 7. 6 times negative 4/3, we multiply by the top, divide by the bottom. 6 times 4 is 24, divided by 3 is 8. It's a negative, so we have negative 8 plus 7. Negative 8 plus 7, y equals negative 1. And so that's the other part of the ordered pair. Now, this took a little bit of work to get here. Is it possible that we made a little mistake in here somewhere? It is very possible. Checking your answer is a good idea. To check your answer, you want to plug the points into both equations. When we plug it into the top one, we get y is negative 1 equals negative 4/3 times 6 was negative 8 plus 7 is negative 1. The other one, 3 times negative 4/3 is negative 4. Minus 8 times negative 1 will be plus 8. So we have negative 4 plus 8 is 4. So it works. Again, checking your answers is super useful, especially in this topic, just because there's a lot of little steps, a lot of little things where you could do something silly that you don't want to do and you'd regret later on. So let's look at another one. This one is a little bit easier, like the numbers just work out a little bit easier on this one. The top one is x equals y plus 6. So we could take this, we could take the x, we could take that and plug it into the x. All right, there's no distribution or anything like that because it's just x there. So if you feel comfortable, and even if you don't, if you have some idea, you think like, hey, maybe I can do this. Pause, try this problem on your own really quick. And then we're going to go over it. See if you can do it. Even if you make a mistake, that's going to help you. So pause your video right now, work this problem, and then when you're done, push play and then we'll go over it, okay? Did you do it? Did your answers come out to be something a little bit nicer than the first one, maybe? Well, let's take a look. So I already said we're going to take the x and we're going to plug that in. So instead of x, we're going to have y plus 6. And then we still have plus y equals 10. We can get rid of all the stuff that's not the variables. So minus 6, minus 6. We can combine our like terms. We have y plus y is 2y equals, come on, pen, you can do this. Equals, there we go. 10 minus 6 is 4. To get y by itself, we divide by 2. And so y equals 4 divided by 2 is 2. Oh, hey, that was a lot easier. Let's take that and plug it into the top one. So x will equal y, which was 2 plus 6. 2 plus 6, x equals 8. Let's plug that into the bottom as x plus y equal 10. 8 plus 2 equals 10. Yep, so there's our check. Our answer, remember, is an ordered pair. And even though we found y first, remember, ordered pairs go x comma y. So this is going to be 8 comma 2. Putting those in backwards, especially when you found them with y first, is a fairly common mistake. So make sure it's x comma y. How did you do? Did you do okay? If you made a mistake, did you see your mistake? Did you actually pause the lesson to work the problem? That's the first step. Even if it's a struggle, even if it's hard, that helps with the learning process. Even if you make a mistake, then when you see it, it's like, oh, all right, chances are you won't make that mistake again. All right, you're in luck because we have another one that we're going to look at. Another chance for you to try this out. This one's going to be very similar to the first one that we did. Notice the setup is almost the same. Y equals something, and then something times x plus something times y equals something. So the steps are going to be pretty much identical. As opposed to that second one, it was a bit simpler of a problem. So again, pause your video, work the problem, and then when you're ready, come back. So all right, so let's take a look at this. We're going to plug in the 2x minus 1 for y. So we're going to have 2x plus 3 times y equals -7, but instead of y, we're going to have 2x minus 1. We need to distribute that 3. That'll give us 2x plus 3 times 2x is be plus 6x minus 3 equals -7. We can move all the non-x's to the other side and combine our like terms. So 2x plus 6x is 8x equals -7 plus 3 is -4. Divide by 8. Divide by 8. So x equals -4 over 8 is -1/2. All right, let's plug that in to the top one. Y equals 2 times x minus 1, where x is -1/2. 2 times -1/2 is -1 minus 1, so y equals -2. Does that work out in the bottom one? So let's see, 2 times -1/2 is -1, plus 3 times -2 is -6, so -1 plus -6 is -7. That works out. So our ordered pair is -1/2, comma, -2. All right, so solving systems of equations, it's the same thing. Over and over, we're just using substitution. We solve for a variable, plug it into the other equation. That gives us one variable and one equation. We've done that before. Notice the work is the same as we did a few chapters ago. And notice this is one of the reasons why we learn how to show our work, because there's a lot more steps here. It's not quite as easy where you can just kind of see the answer for some of you. All right, let's take a look at another problem. This time, we're going to do a word problem. We've seen these types of word problems before when we were graphing. So we have vacation resort offers surfing lessons and parasailing. If a person takes a surfing lesson and goes parasailing, she will pay a total of $175. On Friday, the resort collects a total of $3,101 for activities. How much does each activity cost? So we need to give them names. Here, it actually gives us names for it. It says let X be the price of surfing and Y be the price of parasailing per person. You could have used S and P. I tend to avoid S's just because they look a lot like 5s, but you could do that. You could call it whatever you want. Here we use X and Y because we could also graph this one. This problem was, hey, look, we graph it, we solve it algebraically, which one is easier? We're going to see that without actually graphing it. And we have our equations. So this first one, a person goes surfing and parasailing, it cost her $175. And then from over here, we know that 16 people go parasailing, 20 people go surfing, so 20x plus 16y equals that $3,101 that the resort made that day. So we have set these types of problems up before. The first step here is let's solve for a variable. We have x plus y equals 175. So let's solve for x. So to solve for x, we just need to subtract y. So x equals 175 minus y. Why would I solve for x instead of y? No real reason there. I mean, it was both basically the same. It didn't matter too much. With a little bit of practice and experience, though, you look at the other equation, we have 20 times x plus 16 times y equals 3101. And then we can plug in what x was, which was that 175 minus y. Why would I choose x instead of y? I'd rather multiply it by 20 than by 16. That's really the only reason to pick x over y in this case. Multiplying by 20 is just a little bit easier. So, let's do this. 20 times 175 is 3,500 minus 20y plus 16y equals 3,101. We can subtract to get the variables. Combine our like terms. Negative 20 plus 16 is negative 4y equals 3,101 minus 3,500 is negative 399. And next step, divide by 4, negative 4. It's good that they're both negative because then they end up as a positive. And we get y equals 99.75. Costs $99.75 to go parasailing. Okay, we can plug that in to one of our equations. I recommend plugging it into this one right here because 175 minus 95.75 is going to be definitely the easier equation to deal with here. So x is going to equal 175 minus that value, 99.75. So x equals 75.25. So in this case, it could be an ordered pair. We could write this as an ordered pair because we do have x and y. So we have 75.25 comma 99.75. But an ordered pair here doesn't really make sense. Like surfing is x because we said so. Parasailing is y because we said so. I mean, if we graphed it, yeah, we'd have x and y. A sentence here would be better. So it surfing is 75.25 per person, and parasailing is $99.75 per person. So we solved it. It came out the same. It did require some decimals. Like this is one where having access to a little calculator can definitely help you in the computation part of it. The part of this question was solve it by graphing and solve it algebraically and see which one's easier. And so people are like, oh, well, graphing's always easier because you just look at it. Look at our answer. If you're graphing, how accurate does your graph have to be to get the point 75, 0.25, and 99.75? It doesn't hit a nice number, and then it has to be big enough to actually include those values. And so to do that, like it loses its accuracy or it's going to be huge. And so to try to find that in a graph is really quite difficult. And that's why solving algebraically is going to be the go-to most of the time. Solving algebraically gets us the exact answer. We don't have a lot of weird stuff to try to deal with. It's the way to go, unless it specifically says by graphing. Some more systems. So here we have y equals 3x plus 1 and 6x minus 2y equals negative 2. Same thing. Nothing changes here. We're going to take this stuff and we're just going to plug it in. So we get 6x minus 2 times y equals negative 2. And y was 3x plus 1. So we can distribute that. So we get 6x, distribute the whole negative 2. So that'll be a minus 6x. The negative 2 times 1 is minus 2 equals negative 2. Here, if we combine our like terms, 6x minus 6x, we get negative 2 equals negative 2. If we had added the 2 over, we'd get 0 equals 0. What happened here? What happened here is the same thing that happened sometimes when we were solving equations. Our variables disappeared. When variables disappear, we have two options. What's left is either true or what's left is false. If it's true, that was the identity when we were just dealing with equations, and we ended up with all real numbers. It's still an identity, but we don't have all real numbers. This is where we get infinite solutions. And remember, graphically, this happened when it was the same line. If it was false, it's called a contradiction. There's no solution. And this happens when we have parallel lines. Because there's no intersection point. So if we looked at these two, if we graphed these two, we'd see they were the same. If we took this bottom one, the 6x minus 2y equals negative 2, and we put it in slope-intercept form, that'd be minus 6x minus 6x. So we have negative 2y equals negative 6x minus 2. Divide everything by negative 2 to get y equals negative 6 divided by negative 2 is 3x. Negative 2 divided by negative 2 is 1. Notice that these are actually the same line. We don't have to notice it beforehand, though. When our variables disappear and we're left with a true statement, that means that there are infinite solutions. Well, what's the other option? Here we have 5x minus y equals -4 and y equals 5x minus 4. This time it's the bottom one that's already solved for us. Doesn't matter, we'll just plug that into the top. So we have 5x minus 4 equals -4. And right away you might be thinking like, wait, this is going to be the same. No, always do the math. We're going to distribute that negative sign. So we get 5x minus 5x plus 4 equals -4. 5x minus 5x is 0, so we have 4 equals -4, which is not a true statement, and so this is no solutions. Here, if we took this top one, we could move the y over, add the 4 over to get y equals 5x plus 4. Notice they have the same slope, but different y-intercepts. That means that they're parallel, and so there's no solutions. Again, we don't need to notice that beforehand, though. The variables disappear on us. It's like, oh, what do we do? Oh, wait, the problem's basically done at that point. We just have to figure out if what's left is true or false. All right, one more nice little modeling problem. So Nate starts a lawn mowing business. In his business, he has expenses and revenue, as any business. Nate's expenses are the cost of the lawnmower and then gas. So the cost of the lawnmower, that's a one-time thing. Gas is gonna, like the more he mows, the more gas he uses. So that's gonna be a consumable. That's gonna be a rate. And then his revenue is $25 per lawn. At what point will Nate's revenue exceed his expenses? So we do need to know a little bit more about this. We need to know how much the lawnmower cost, how much gas does he use, and so we do need some information. Lawnmower costs $200, and the gasoline is $2 per lawn. So let's say X equals the number of lawns, and then Y is going to be the cost. Now we could use revenue and expenses. We could do like E and R, or we could just use Y equals the cost, either the cost he's paying or what he's getting in. So for his expenses, Y will equal, he had to pay $200 for the lawnmower, and then he has to pay $2 per lawn, so we have 2x. So if he mows 6 lawns, 2 times 6 is $12 in gas, plus his $200 lawnmower, he has spent $212. So that's his expenses. His revenue, what is he bringing in? Well, he's making $25 per lawn, or he's charging $25 per lawn. So we have 25x. He doesn't start out with any like supply of cash that somebody just gave him just for the fun of it. So we have y equals this, we have y equals this. Sometimes when people have y equals and y equals, they kind of freak out. It's like, well, what do I solve for? Well, if y equals 200x plus 2x and y equals 25x, doesn't 200 plus 2x just equal 25x? I mean, you could substitute either one of them in, it doesn't matter. So we have that. We can subtract the 2x over. So we get 200 equals 23x. And then we're going to divide both sides by 23. to get x equals 8.6956, so about 8.7-ish. That's going to be his break-even point at about 8.7 lawns. Is he going to mow 8.7 lawns? Better question. If he stops at 0.7 the way through the lawn, is he going to get paid? Probably not. So even though his break-even point is 8.7, he's in the middle of that 9th lawn. He's going to have to finish that. So his revenue will exceed his expenses after 9 lawns. So once he mows his 9th lawn, he's going to have made a little bit more money than he pays. And then everything after that, he's making money. He's paid off his lawnmower, and he's charging more than he's paying in gas. But he has to make it to 9 lawns first, and then he gets in the black. So this is solving systems of equations by substitution. We'll look at another method next week. This week it's all substitution, and again, notice it's the same thing over and over and over again. So I will see you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.